Hello everyone, my name is Peter Kwan. I'm the chairman of the Institution of Facility Engineers and Institution of Data Center Engineers. Today I'm going to talk about the data center operation and maintenance for maintenance technicians, engineers, senior engineers, and facility managers. Well, this is the first part or elementary course for the data center technical diploma. There are 5 courses in the technical diploma for data center engineering. This is the first one. The second one is about data center system design for maintenance engineers. It consists of basic system design like air conditioning, electrical supply, fire surfaces, and plumbing and drainage for the maintenance people, because usually maintenance people have slightly weak knowledge in system design. So this provides a basic design concept. The third one is more advanced course, which is for the data center design and construction management. Here, the data center we mean by small data centers to medium-sized data centers. And then the fourth one is called the data center air conditioning design, which is more to do with the CRAC units, chiller plant, air handling units, cooling load, that sort of things. And the last one of the technical diploma is the data center electrical design, which is to do with the normal power supply, the essential supply, UPS supply, and all the electrical works. So maybe let us start first. If you have any question, you can send the email to me, my email address is pedtdrkwan1689@gmail.com. Okay, so it's pedtdrkwan1689@gmail.com. So let's start first. This data center operation and maintenance actually is edition 18, because in the past we have run it in Hong Kong for the government departments, the IT department of some universities in Hong Kong, and also some in-house training for large organizations, as well as in the Hong Kong Productivity Council and in Macau as well. So this course would be separated into 12 topics and would be around in 4 lectures, hopefully. The first one we talked about is the emergency responses. The second one is about the M&E plant in general. What are the M&E plant in data centers? And then we'll look at the critical systems of the data centers, and then maintenance management. What are the maintenance management in the data center? Then number 5, we talked about the comms room equipment. What are the equipment inside the comms room? And then number 6 will be maintenance strategy. Number 7 is the individual plant. Let us talk in more detail for the HVAC and the electrical supply, like the UPS, the CRAC unit, chiller plant, that sort of things. Item 8 will talk about the common breakdowns and resolutions methods, how to resolve this problem. And number 9, we talk about office area maintenance, because most of the small data centers are incorporated into offices, like banks' offices or universities, right? And then number 10, we talk about preventive maintenance, right? Preventive maintenance is still the best maintenance strategy for data centers. And by request from the participants or students in the past, they always ask about the CRAC and UPS system. That's why 11 and 12 we talked about UPS and CRACs. So let's begin. The contents. So for this today's lecture 1 here, we try to talk about emergency response, M&E plant in general. We will try to talk about 3 and 4 as well, but let's start with 1 and 2 first. Data center operation and maintenance. Let me tell you a story of a gas plant explosion in Hong Kong about in 1992. Okay, that's almost 30 years ago. I remember those days there was a real case that a gas plant in Hong Kong. It was a gas plant there, and there were 2 engineers working inside there. One engineer working on one thing, the other engineer working on the other thing, and suddenly they heard a warning alarm. And engineer A, by training, run towards the nearest fire exit or escape door. And engineer B think for the moment and we run for the opposite direction of the nearest fire escape route. At the end of the day, engineer A died and engineer B survived. So the court has asked for a coroner investigation. Why engineer A run towards the nearest fire escape route and he died? And there were a lot of professional people and expertise, and then including some government departments, safety officers, right, all involved there in the court. And what I heard there was the engineer A died because when he heard the alarm, he ran towards the nearest fire exit. But the alarm is actually on the nearest escape route that he's trying to go through. That by the time he passed through that gas plant, unfortunately the gas plant exploded and he died. Engineer B heard the same alarm, and he was close to engineer A as well, of course. But he thinks and he thought about it. He heard the alarm in that direction near his nearest escape route, but he runs towards another alternative fire exit and he survived. Nobody is to blame here. Right? It just requires some sort of a thinking. So I'm going to talk about this in the 1.2 emergency procedures, but let's start with some basic response here first of all. And then in this lecture, we'll talk about equal list, BCP drills, and coordination and communication. And I will give you a case where we have a client which got a data center in Beijing. And then we'll talk about some important electrical power supply system in New Delhi. Now, this course actually is all over the world, but that comprises most of my experience in APAC. So, emergency response. First of all, the basic response, that actually goes back to 1990 when I was working in the hospital in UK. I was always told by my estate manager, keep calm. No matter what happened, keep calm. So keep calm and find out what happened and what are the impacts. Is it power down or some life and death issues? And then who are affected by this incident? Number 2, think for a minute, as I mentioned before in the case of the gas plant explosion. Had the engineer A thought about that, he won't run towards that alarm in the same directions of his fire escape route. But think for the options available. What are the options available here? Number 3, choose the most safest, fastest, effective, and less impact to the others option. There may be a lot of options, right? You need at least 2 to 3 options, but always choose the most safe option. Act fast and inform the superior. A lot of people try to act very fast and then handle it, but without informing their managers or superior, because the superior may have some even better advice or may have some other issue that you need to think about, not just the technical side maybe. So when you call your superior or manager, advising the case, what action you have done, and seek for further information advice from him or her. Right? You're bound to report to him. and alert him or her. If the case cannot be resolved, ask for more resources. Here, resources mainly is the plant as well as the people. I have seen cases that sometimes we cannot resolve the problem, so we have to ask some contractors to come on site to help, or ask for some advice from some experienced people. If the situation has been resolved, pretty good. Follow up, review, and prevent. One of my best learning from an American engineer, actually is Italian, but he always tells me, he said, I don't care what happened now or in the past, but I want to know how you can prevent this incident happening again tomorrow or in the future. So I learned very much from him. And after that, if the situation has been resolved, you must provide training or actions to prevent this reoccurring. So these are the basic response that you should think about. So always keep calm. Now my second thing is trying to look at the emergency procedures. So let me go out here and make a file here. Let's see a file. All right. So this is the emergency procedure which I produced almost 10 to 15 years ago, and the emergency procedures normally consist of two periods. The first one is the office times during office hours. The second one is after office hours, whether it's after 6 o'clock at night time until the next morning, or at weekends or at festival times. Now, because a lot of people that when they were involved here, it could be some junior people. So let's start with item 1 here. So in a case like this, when a critical incident occurs, usually it's the BMS system or the auto dial system or the reporter, incident reporter. Would report the incident. So the first thing is to call the nearest facility manager. Why is it the nearest facility manager? Well, in some cases, there are a lot of data centers by your company. So the nearest manager may not be same at the same data centers. So the first thing is call the nearest facility manager. Failing that, you may want to call him, his or her colleague on the next level up in the sequence. But the responding party is the facility manager, of course. On receiving the critical plant breakdown alarm call, the facility manager must determine whether this is a contractor's work or the client staff can handle the case, or in fact, it is the building managers. Because sometimes the data center may not belongs to your own property. There's another building provider, right, the developer. So you need to find out which one should do this work to save time and effort. Number 3, if the case cannot be resolved or has taken too long a time to resolve it, the FM should alert the regional manager. And the regional manager should be acting as a backup to the FM for further advice. If the situation continues, the regional manager may need to call up the global manager or the head of the department. Number 4, if the case has been resolved, the FM or the regional manager should review and prevent this further happening. Yes, I mentioned before in there. Now, if after office hours, very similar, the incident occurs, BMS, auto dial, or the incident reporter, in fact, now should call the regional security office or the local security head. And from there, the security office or guard should then call the nearest facility manager, who then decide who should be carrying out the investigation, either his own direct staff or by a contractor or the building's developer's contractor. Item 3, if the system cannot be resolved as before, just call for more resources. You may want to call more people to go on the site. If the situation has been resolved, then the FM or the regional manager should review and prevent its further happening. It's the same thing here. Now here, please note that the MMC means the maintenance management contractor. Sometimes we outsource the FM business to the external people. All right, so this is the emergency procedures. Let's go back. Okay, so we'll talk about item 1.2, the emergency procedures. Now, actually, you should also prepare a e-call list as well, which is the emergency call list that may including the standby technician engineers, contractors, emergency phone number, or even sometimes the building's emergency contact after office hours or in the office hours, and then maybe some other like fire department, police department, as well as the environmental agency. So it's a lot of people on that e-call list. Item 4, we should also be prepared to write up a business continuity plan. And this is very common nowadays. Basically, what it is a written procedures to tell people how should we continue with our business, even there are some problems at the moment. I remember many years ago when I was called by my Japanese peer that there was earthquakes and the tsunami. And he told me, I said, how are you getting on? He said, look, pretty bad. And he was calling by his mobile phone under the table because there was an earthquake there. Right, so business plan is important to tell people what should they do, apart from the emergency procedures, what should they do and what are the resources, the procedures, the whole steps. Now, at times, we also want to have drills. The drills is one of the best things to test people or the system or the team, whether they are ready for any emergency cases. And usually this could be done once per month, right? Just to test people. Say, for example, there was some comment regarding the relocation of the old Hong Kong airport to the new Hong Kong airport in Lamma Island from Kowloon. There wasn't any drill there at all, right? If the drill had been done, then maybe we don't have such a hassle that by the time we open the airport, a lot of signaling system or information system are not working because no drills have been done. Well, this is just a comment, right? So drills, we need the drills to get ourselves ready, just like a health check report, how are we getting on? Or some sort of a fictitious imaginary case, like earthquake or explosion, you'll see how people react based on that drilling exercise. And 1.5 is called the importance of the coordination and communication. Well, of course, I forgot about the story of Mr. Wong now, but in any case, most of the problem come from our coordination and communication. I've seen people that they work close to each other, maybe 1 or 2 lines behind the desk, but they send emails to talk to each other instead of going over and talk. That's not good communication, right? And coordination, right? Sometimes we need to coordinate with everyone. Okay, so coordination is very important. Whether you coordinate with your manager or with the vendors, with the contractors, or with the building engineers are very important. So let me show you the second part of the M&E plan in general. There's a case here which I would like to share with you. It's a Beijing case, and it's one of our clients. Let's see how it goes. Okay, I believe you can see my screen now. So this is a case where we have a small data centers inside a building which does not belong to our client, but belongs to the building developer, right? So let's see how it goes. So the office is in the International Financial Center in Beijing. And remember, before we are able to operate and maintain the systems, as fitted drawings, automatic control drawings, an electrical wiring diagram, and maintenance manual must be available for the correct operation of the systems. The M&E installation here, including the HVAC system, air conditioning, plumbing and drainage, electrical installations. EMS is energy management system, or sometimes building management system. And then with FM 200, which is for the fire suppression system, gas system. HSSD, sometimes called VESTA, the highly sensitive smoke detector system. And then, of course, with the base buildings, fire services provisions, which is like the fire sprinklers, fire hose reel, and break glass units. Let's look at HVAC system. Well, in the comms room, there's always a, in the past, we called it a communication room in the office, right? And in this room, sometimes we call it server room, of course, the computer room, server room, or telco's room sometimes. In here, we have a 1+1 independent Emerson CRAC system is provided. CRAC is called the computer room air conditioning system. It's a precision system. There are two numbers of it, right? But in fact, one is sufficient. The other one just stand by or by rotation. The CRAC units have different types or means for cooling, but this one, we're using a 24-hour chiller plant to provide chill water into the CRAC units by the landlord. The sensible cooling per unit in this case is 48 kilowatt at 22 degrees Celsius set point, based on 50% RH. For the office area, because outside the data center is the office area, so in Beijing we have a primary air unit plus to provide the fresh air, and then a fan coil unit for the local cooling. And there are two zones. Basically, it's the internal zone where you cannot find the external wall or the window, maybe somewhere near the center of the building, like the lift shaft areas around there. And they are using cooling only for the summer with a two-pipe system. And for the exterior zones with external wall and windows where solar gain are available, then they will provide cooling and heating with fan coil units with four-pipe system. And the PAU unit, which is primary air unit, which provides fresh air. In the plant room located at the surface core of 11th floor to serve the whole office area. So this is the original design. Now you see the CRAC unit here. We are just taking a Emerson unit, but in fact you can use any unit you wanted. And in the old days, we always used the raised floor. See the raised floor here with some floor grills, floor discharge air grill, exactly, and console. And there are some valves and meters of the CRAC unit pipes, right? And then local control panel like this one. All right. The fan coil unit is something like this, which they put in the ceiling. The room temperature control unit, there are different types, right? There's something like this one with the speed control, room thermostat, in the office area, and then maybe you have some other control unit like something like this. Now this is the comms room here, computer room or communication room. In this case, we can see that actually these are the columns, the building columns, but the two CRAC units are here. And with the sump pump, I believe, which is to pump away the condensate or the drain. There's a battery there and UPS. RMM is something like it's a power monitoring unit. With the main distribution panel or PDUs, inside there are about 5 to 10 number of rack units. And there's some patching panel here. There's also some other things, right? Like The exit sign, there's a door here. The door actually is over. See the D13 is the door. And then we have a security panel as well, and some other things there. Okay, this is typical small comms room or server room for the bank or for an office building. Now the chilled water, as I mentioned that the CRAC unit use chilled water. The chilled water is 24 hours by 7 because the data center or the server floor is 24/7. And then for the office area, it's Monday to Friday, and there's a time that 8 o'clock to 7 p.m. Saturday is only half of the day. Sunday, public holiday, the office area have no air conditioning at all. But that's subject to the lease of the landlord. The hot water supply, because it's in Beijing, that's why in China the winter time start maybe in November 15 to 15th of March, and maybe even early in October. But definitely within this period, November to March will be pretty cool. The starting and ceasing dates of the provision of the hot water is determined by the landlord, of course, according to the weather conditions. Again, same thing, follow the office hours, right? Condensing water supply, right? So as I mentioned before, for the CRAC unit, provision of the condensing water or the chilled water for the comms room AC is available throughout the year at 24 hours, right? Depending on what type of CRAC unit you're using. Using chilled water, using refrigerant, right? So it depends on what kind of CRAC unit you're using. But basically, it's 24 hours by 7, 365 days. And this one obviously is using a condensing water to cool down the direct expansion unit. And here we also got some, within this area, we see some red dots here. Actually, these are the main valve, right, for the chilled water. You see there's a lot of columns here, and there's a lot of fan coil unit here, I believe, right? So, but there are major valves that in case of water leak, you need to know which one to shut off to condense, to contaminate water leaks. Primary air supply, right? There are 4 number of PAU systems providing fresh air, which is located in 4 AC rooms inside the building core on each floor. In this case, one of the PAU is serving for office, and the PAU duty is about 5,000 meter cube per hour at the 300 Pascal external static pressures. And ductworks are connected from these PAUs to the occupied rooms. And comms room, because it is such a small data center area, we do not need to have fresh air. Again, the PAUs operating in this time, right? And the supply air temperature of the PAU in the cooling season will be around about 24 degrees Celsius, and in the heating system, the winter time will provide at 18 degrees Celsius. And any additional cooling or heating will be provided by the fan coil unit itself, because it's a 2-pipe or 4-pipe system. Local fan coil unit will provide that local cooling and heating. In this case, there's a FM200 together with exhaust fan. By law, if FM200 gas had been discharged, there should be exhaust fan to exhaust the FM200 gas. This is because the FM200 gas is basically toxic, non-toxic, but if the FM200 reacts with some other chemical, it may become toxic. That's why we need to have exhaust fan once it's discharged, and should be able to be manual or automatic. So the comms room, the server room, is protected by the FM200 system, where it's provided with exhaust fan, exhaust ductwork connected to the outside. So for example, this is ductwork and this is the control panel. For the office area, we have We have a supply PAU here. We set, this is the exhaust fan of the FM200 gas, which is here. The exhaust fan is over there. But this is the PAU system, which provide the basic and fresh air to the area where the fan coil unit provide extra heating and cooling. But the exhaust fan for that server room is here and discharged to outside or there. Comms room, because we have two number of CRAC units, one duty, one standby, and should be by rotation as well after a week or something, or even a month if you want to. It's a sequential control. In case one unit fails, the other one will quickly cut in. The failed unit will be manually reset and become the standby unit. In this case, control of HVAC system, the operation of the fan coil units locally is simply by a on and off control with a 3-speed switch, as you might have seen. It could be low speed, medium speed, and high speed, depending on the airflow you want. And fan coil unit in small meeting rooms and reception area, the temperature was preset at 22 degrees Celsius with a thermostat at the return air plenum to sense the return air temperature. The landlord can control the power on and off for the control valves of the fan coil by BMS, and the end user may only have fan coil unit fan operation after office hours. That's why I'm saying that the cooling is controlled. The cooling and heating is controlled by the valve via the BMS. So in the case here, you see a lot of the fan coil units. This, I think, the green things here, right, all over the office area. And the schematic diagram for the fan coil unit controlled by the BMS while the landlord is the BMS have a 24-volt control the relay for all these fan coil units. Right, it shows from here T1 to T32 or whatever. Now the FM200 exhaust fan, and the exhaust fan is controlled by the starter panel in FM200 room outside of the comms room, so it can be manually done. In case of the FM200 gas discharge in the comms room, the competent person or authorized person, like the engineer, can activate the exhaust fan after the fire has been extinguished by pressing the fan start button at the panel. The exhaust fan is then interlocked with the fire and smoke damper at the exhaust grill inside the comms room to get it opened. Plumbing and drainage system. In this case, we because it's an office area, then not a lot of people, then we shall use a 2.1 kilowatt instantaneous type electric water heater. Emergency water valve, sometimes we call it EWO, emergency water off, which is in case there's a fresh water leaking, then because it's a raised floor, right? So you want to cut off the water, so you can hit off this emergency water off valve, EWO. That will turn off all the water supply coming into the area. Drainage system, drainage, because for those areas which they could not return the drain to the nearest draining point, then like in the middle of the office area, we install some kind of a drainage tank or some tank below the wash hand basin unit. And in the comms room, as we mentioned before, the CRAC unit may have condensate. And if it is too far away to drain the condensate to the nearest drain point, then we have to use a small pump to drain it, to discharge this into the sump tank. Here, sump tank here, right? Sump tank here. And then with the pump, a pump to the nearest drainage point. And this is an example of a sump pump panel and sump tank. For example, here we can see the red dots. Right, the red dots means for the sump pump and the valve here, here, and here. And the sump pump lies one inside the server room to pump off the condensate from the CRAC unit. There's also one in the pantry area. In this case, water leak detection, because we are using a raised floor here, so inside the comms room, we install a water leak detection system, and with the cables running around, right? And usually this water leak detection system has a simple electrical wiring cable, which when the water is present, then it would change its resistance, and can also count how many meters away from the main panel that you found water. Let me see if we can have a more detailed drawing, but you can see the drawing here, the red line shows the water leak detection cable, like here, for example, right? So in this computer room, actually, although it's indicative that the control panel is over here, but the cable, the water leak detection cable is running alongside of the four walls, and maybe also below the CRAC unit, because the CRAC units always have some water tank, right? In case the water tank leaking over, see, you have some cables, but in fact, it should be right along the wall. Actually, this is indicative. And in this comms room, there's also some, I think there's some water pipes above the room, like this one, for example, or there's some other things above the server floor, which we install some sort of a drip tray, and then with the water leak cable surrounding the perimeter of this drip tray. The same thing applies here as well, I think. Yeah. Okay, so if there are some other water resources, right, which you don't want this raised floor to be filled with water, so you also install some sort of a water leak detection cable, especially where under the pantry floor, right, pantry area. Okay, so electrical system. In this case, we have some low voltage panel, right? By low voltage panel, we means voltage normally is 220 and 380 or 415, but less than 1000 volts. There's also some other power distribution systems, distribution board, and essential power, for example, and then lighting and trunking conduit provision for those extra low voltage, like IT cables, IT supply, security system, audio visual and television cables. These are all normally below 50 volts or 24 volts or even 12 volts. We call it extra low voltage. Well, this drawing is too small, but I'll show you some other later on. But basically, you can see that the power supply comes through here and then goes to there through a ATS, I believe. Right, through ATS, and the ATS will select the normal power supply to supply to the distribution board, and from there go on to the UPS system. And this UPS will supply to all the IT load downstream, while this panel will also provide some other services of CRAC units or whatever inside the server floor. There may be another power supply coming in to supply all other lighting and socket outlet, computers, that sort of thing. So in here, we have two power supply, one for the server floor, one for the other general office lighting and power, that sort of things. And they are separately metered because we want to measure the total power in the server floor and the total power outside, and don't mix them up. And also important to notice where is the main distribution board, right? So in here we have a main distribution board here for this side of the office area, and there's also one here which is for this side of the office area, and there's also one inside for the server floor or comms room. Okay. So inside you will see some kind of a panel like this one, right? It's like LV panel or PDUs, distribution panel, all these things. And the ATS, we mentioned about the ATS. The ATS is a device which is called the automatic transfer switch, which select the normal power in all cases. But as time goes on, when the normal power breaks down, it will switch to the essential supply right away. And normally, the ATS would take the alternative source of supply, either by the supply company or by the genset. And normally for the comms room, right, the power supply to the comms room usually have 2 feet, right? At least 2 feet, 2 power cable goes in. And EPL means the emergency power and lighting. So the LV panel is installed to suit the power supply and distribution system. And in here we have the power distribution board installed at the following rooms, right? The comms room, I think we saw this one before, which we also got UPS there. And then the external bypass, which we talked about. SPM is a kind of a power monitoring system. And also sometimes they may filter some harmonic issue as well. And then, as we saw before, there's one main control panel on the north side and one on the south side. You remember there's one there and one there, right? The NP means normal supply. All right. Okay, so inside the server room or comms room, you'll find some UPS, right? I think this is the UPS and the battery is over here. And there may be some other monitoring panel. I think this is one of the power monitoring system. So in the electrical system, you can see here, in this case with the UPS, as I mentioned before, UPS is called the uninterruptible power supplies. Backup time could be 5 minutes, 10 or 15 minutes, or maybe 30 minutes at the most, unless you are in a country or in cases where you might have a prolonged breakdown and the genset is not available, then you may want to go up to longer times. But normally, less than 30 minutes should be fine, or even 15 minutes should be good enough. Okay, the SPM is just a precision power output with monitoring and recording power supply history. MBP is the some kind of a manual transfer of normal power in case of UPS maintenance, so kind of a control panel. This is a distribution board where you have general lighting and power, right? It's quite familiar with you now. And the landlord usually provide kind of a fluorescent lighting system with 4 number 18 watts T5 3000K color rendering fluorescent lighting. This office is a bit strange as well, because apart from the normal power, they have some special lighting and also it's a sign, directional sign in the corridor. But on top, there's also some motion sensor to control lighting in the meeting rooms, which is very common nowadays, especially with the beam system. And then there are some other light fitting which they use at least 2 hours battery kits, right, for emergency lighting. This is depends on the local requirement, local fire office requirement. There's also some daylighting control in this case, because these are the window area, right? So in this office, they provide the lighting control, daylight control. If the sunshine is good and tremendous, then they may switch off some of the lights around this area, or may also call the blind to come down or turn the angle of the blind to shut down some either the lighting or the blinds to come down to shield the sunshine to reduce the air conditioning loading. Motion detection we mentioned about in the office area. Okay, so and also the energy management system, right? Energy management system monitors the alarm from different systems, something like a BMS system, right? Say in this case, they have the monitoring for the CRAC units, the high sensitivity smoke detector, which sometimes we call the surface Vesta system, UPS, FM 100, 200. If it activated, the BMS will send out a signal. Condenser pump tank as well. It will tell people who are on maintenance that condensing pump has got problem, or water leak detection has activated the alarm, or the comms room has high temperature. Right. So these are all the by the energy management system. Well, in theory, this is a block diagram to show this energy management system or environmental monitoring system. They have power supply, monitor power supply, monitor UPS, if it's activated, CRAC units, CRAC 1, CRAC 2, some temperature of the room, then connect to network to send emails or auto dial system to those people who are on call. Drain pump, if the condensate pump or the drain pump is malfunction, then we send a signal to the control panel. Control panel sends signal to the others. Water leak detections, Vesta system as well as FM 200 if activated. So it's quite like a building management system basically. Well, don't forget there are extra low voltage as we mentioned, right? We have AV, IT, and security system. And all this would have to be with extra low voltage and should be separated from the normal 220 volt or 380 or 450 volts, right? Because they're usually very low voltage, like 50 volt, 24 volt, or 12 volt. We should also have the electrical meters. We mentioned this before, that we have supplied to the comms room, we have supplied to the office area, and each should be individually metered. Right, like this case, right? So meter there, there's 2 meters, then one here and one there. FS system. Now here we use the FM 200. FM 200 is quite common in inert gas. In case of this fire, this FM 200 gas will start to spray onto the comms room. The gas discharge nozzle with smoke and heat detectors are located inside and also under the floor, below the ceiling or above the ceiling as well. So activated by the smoke detectors or heat detectors. And any smoke alarm interface with the automatic fire alarm panel. Right, and then any crawl zones detection by the smoke detector or heat detectors, it would activate FM 200. And at that time, when the FM 200 is discharged, the CRAC unit would also shut down. So the cooling would be gone. Because that is to allow the smoke detectors able to pick up this FM 200. Or when it's required, you don't want the gas to run around, right? You want to shut down the fan to blow the gas, FM 200 gas away, right? And normally this FM 200, like this schematic diagram, it requires some special software and specially approved by the fire department. In this case, I think you should be able to see there's a number of pipe size, 25, 25, and then the down nozzle, 1 here, 2, and 3, right? Some are the FM 200 cylinders here. Some are, as we mentioned, some are below the raised floor, some are below the ceiling, some are above the ceiling. If the ceiling above is more than something like 900 mm, but depends on which country you are. The HSSD, sometimes called the Western system, basically it is a kind of a high-sensitive smoke detectors. It's an active smoke detection system because it keeps drawing air to compare with the standard inside this panel, or compare the standard data inside this panel. So it's an active system basically. So when there is a fire, the smoke or the dirt will be inside the room, and then the active sampling taken will compare with the basic standard data that this alarm panel has stored. If they found some differences, they will activate the alarm. So it could be quite sensitive sometimes, could have some early, sometimes we call it early, but that's why for very early smoke detection alarm system, right? Sometimes too early, maybe. But in this case, the Western system is inside the server floor, and again around the perimeter, basically. Or sometimes could be over the CRAC unit, right? Because if the CRAC unit got CRAC keep drawing the air in the return, and if any smoke or dirt above the CRAC unit, then this HSSD system would pick it up. There's also some other fire extinguishers here, right? Maybe one inside the server room, one outside in some other areas as well. This is a standard fire services department's requirement. And some of them are using carbon dioxide. Right? And carbon dioxide and FM200 inside the server room, and then some other ABC fire extinguishers. It could be water, it could be powder, and all these things, or gas, right? There's also some other sprinkler system inside the office service as well. And when you install the FM200 system, right, you may need to take away the sprinkler head inside the server room. But in all other areas, because you are changing the layout, you might need to relocate some sprinklers or smoke detectors. Also, there may be some fire trip for AV broadcasting. And also, sometimes we use the security and door release, right, in case of some fire alarm where the door is suddenly open, normally open, but now become closed. Interface with the FM200 and the gas discharge. Right? There may be some other fire shutter as well, right, in the main lobby and workstation area. Workstation means the computer area. Daily operation, so we don't want to talk about it, but basically as the operation of the CRAC in the server room and the operation of the fan coil unit. FM200 exhaust fan we talked about, starting and stop page. It's a manual one, actually. It's a manual. Some pump we talked about. This is automatic. Right? Of course, you can also use manual means, right, to start to pump the some water or the drain water leaks, right? Water. Okay, so we talked about this boiler and the emergency water off valve as well. But as we mentioned before any electrical system functioning, we must have the maintenance information, like the electrical diagrams, LV switchboard, layout panel, the circuit charts, power distribution and lighting layout, all these things, right? And then the other equipment. And then every day we should take some readings, right, regarding the voltage, current, the power consumption, just to keep log. The lighting system usually on and off, as well as some motion sensor or solar control, as we discussed before, so we don't want to talk about this one. FM200 we talked about. And the important point here is for the CRAC unit inside the room, once there's a fire signal, the CRAC unit will stop and FM gas discharge will be activated after 30 seconds. So good luck for you if you hear the FM200 alarm sound off. You must leave that area within 30 seconds. Otherwise, you will be suffocated with no oxygen inside there. Right? But of course, there's a manual bypass switch to stop the FM discharge gas if you're sure that there's no fire or it's a false alarm. Usually, there will be a fire control panel inside the server floor as well as outside the server floor, right at the door or the exit door or the main door. Right? But once it's activated, in 30 seconds, if you don't touch the bypass valve to stop the gas discharge, it will discharge within 30 seconds. So you need to exercise yourself in how to run from the server floor to outside the server floor in 30 seconds. Sounds easy, but in case there's no lighting, so that's why in the control room, in the server floor, there are emergency lighting inside as well. And the other thing is about the maintenance. So we'll talk about this maintenance later on, but basically you just carry on regular maintenance, right? Whether it's weekly, monthly, bi-monthly, quarterly, 6-monthly, or yearly as well. Make sure you have the emergency contact list. Okay, so this is the case that we have seen. So let me go out and show you the last one before we finish off this lesson 1 here. We can do this. All right, so we just go there. Yeah. Okay. Let's go back to the last one, which is a important diagram for you. Now, okay, let me come back here. Here we go. Okay, so look at this one, right? This is a very important diagram. In fact, this is a very simple power supply in one of our daily office of our clients, right? And the important thing here is you look at this drawing, although there's some handwriting there, but it's very clear that you can see there's a 105 amp incoming distribution board. It's a very small one, maybe this one, right? And then go there, you through some switch, isolation switch, then you come up with a meter, I believe there's a meter, and then go through to this small distribution panel. This small distribution panel goes to different outgoing circuitry, but definitely one of them, although it's very small, let me see if I can blow it up. Yeah, so blow up like this, right? So you can see that the main supply coming from here and kilowatt hour meter there, as I mentioned. There are 1, 2, 3, 4, 5. There's a 5 circuitry there, or actually 6, right? There's another one going out from here to there. But these 5 of them, 2 of them go to one go for the UPS, which is 33 amp. There's another one here goes through this small air conditioning distribution board. One for the server floor and one for the There's another one here, 10M for the AC. There's also one, as I mentioned, it goes on to the server room. From here, you can also see there's another backup generator supply. So this is the essential side, of course, right? So likely this goes to the server floor. Then you can see also a UPS distribution panel. From there, you have a, let me see if I can make it larger again. Right, we can do it better, right? So from here, you can see that there is a UPS input. 100 amp and another 40 amps, which go to supply a 6 kVA UPS. Another one supplied to a 20 kVA UPS. Right. From there, this 20 kVA UPS also go to the output of a 100 amp isolator, and then provide to these two circuitry. One go to the workstation area, which means some computers, they may use UPS supply. In case there's no power supply, the UPS can still provide power to these computers, likely for those managers or security people's computers, or some bank, they may have some UPS supply. The other one goes to here, which supply to this static switch. Right, and then there's another supply from here which provide to this static switch to go to the server room. So the server, the racks are using this power supply. They both provide 32 amps here. So there's still supply in case one goes down, you still have the other one coming in, right, through the two different UPS. Okay, so it's a very important diagram that you know. Right, for example, the total load is 105 amp. The two 6 kVA UPS use 20 amp. 20 kVA UPS also 15 amps, right? Of course, looks like it's a single phase. This is a three phase, I believe. And UPS room air conditioning also use 22 amp, right? Because the UPS itself, right, need air conditioning. Server room air conditioning 27 amps. Conference room air conditioning 10 amps. Lighting, deep total load on genset again provide 35 amps. So this is a very small area. Okay, so today's our first lecture regarding the lecture 1. If I can recall, let me go back here. So today we have talked about the emergency response as well as the M&E plan in general. This is the first of the first lecture of this data center operation and maintenance. And here we talked about these two things, right? The emergency response, the basic response to keep calm, the emergency procedure. As I mentioned before, you have a office hours response as well as after office hours response. You should have an e-call list, right? Emergency call list, including the contractors, police or fire officers, or the managers. You should also have business continuation plan and drills. Drills is a kind of a test, sudden test. Now, most important is the coordination and communication. And we show you a case in quite a long length about the a small bank, which they got a small server room in that office area. And we also tell you about the example of a small power supply, where you have the normal supply and the standby supply. The standby supply is supplied to the UPS. From UPS, it goes to the IT servers or important computers. So that finished off our today, the first lecture. So I hope you continue with the next one. The next one is again more important, which we want to talk about. Let's see. We want to talk about the critical systems and then maintenance management. So thank you very much today. We'll stop here today. Let's go on to the next one. The next lecture is on 3 and 4. Okay, thanks.